Okay, so we talk about geometry is using deductive reasoning. Okay, so we start with 10 axioms. And on that, we start based on the first flow. Now, the first flow is it's a triangle. Triangle congruency. Okay, so the congruency is basically if you have two triangles, and A, B, C, and another triangle, D, E, F. So there are three conditions. If we know one side and the other side congruent, then the second side, which is congruent to, say, AC equal to DE, and then the angle are also congruent, then we know these two triangles are congruent. So this is called SAS. It's called side angle side. So that's what we named before. The second one is if we know two sides are congruent, one side congruent, let's say if we have AC equal to DF and the angle A is congruent to angle D and angle C is congruent to angle F, then the triangle are congruent. So that's angle side angle. So we have this angle and that angle congruent, and this side and that side are congruent, and also this angle and that angle congruent, then these triangles are congruent. Good. So are we okay here?
Yep. Yeah.
Okay, so we have side angle side and angle side angle. And the last one is if all sides are congruent, then the triangle is congruent. Okay, so it's not that obvious. I mean, to prove, we actually have to prove it. And so we have something actually just a little bit right under the first floor based on the 10 axioms. So that's called side, side, side. Good?
Yep. Yeah.
Okay. And I think I showed you application of that is when you're trying to measure a lake. Now, all you have the yardstick and you want to measure the width of the lake of obviously, like, you cannot just take a boat going there because you have to you only have a yardstick. You don't have anything else. And so what you're going to do is you put two marks, maybe two sticks. One is on A, one is on the B. And all you need to do is actually you just keep going. Doesn't matter which direction. You just keep going in one. And then you go back to B. You're going to walk towards the other side. So you're going to have a point intersection. So let's say this is our C. And now within that, you keep going on this side, have the same distance. So let's go here. Let's say this is our D. So your CD is equal to CB, okay? Same thing, you follow the same direction, just keep going, and same distance as our AC. So this lens is congruent to that lens. And so this one we have now is our E, A, B, C, D, E. And as long as AC equal to DE. And then now if I have these 2 points, now cross this point, you can draw a line. which is one of our axioms, one of the postulate. So got DE. And then once we have that, we know that DE is equal to congruent to AB. So now instead of just like get through the lake, which you cannot do that because the only thing we have is the yardstick. We don't have anything else. Of course, we can draw the line on the land, and then we basically, instead of measuring here, we measure here, and that is the same as basically DE is the same as AB congruent. Good.
Yep.
Okay. So geometry has a lot of applications in a practice or a science called surveying. That people trying to draw the map. But how do we know this is true? How do we know DE is equal to AB? So that's where we need to use one of the theorems on triangle congruency. So we know AC is given. We have CD equal to CB, CD congruent to CB, and DE is congruent to AC. So we have two sides are congruent, and also the angle is called the vertical angle. Now the vertical angle is always congruent, no matter how you draw it. Here is congruent, or you go like this, and those vertical angles are always congruent. Okay.
Yep.
Good. And so now we have side angle side, which means the triangle ABC is congruent to triangle DEC. Because those two triangles are congruent, so therefore all the sides have to be congruent. So DE is one side of triangle DC. AB is the side on triangle ABC. So therefore DE equal to AB. Good?
Yep.
Okay. There's one thing I probably haven't taught you, that is the congruency of vertical angles. I mean, to prove it, vertical angle congruency. So basically we're saying, okay, if we draw any arbitrary two lines and they have intersection. So let's pick a point here is A, point here is B, and this one, let's say is C, this point. And pick point here, this is D. Pick point here, that's E. So we are saying that basically the angle ACB is congruent to the angle DCE. Basically, this angle and that angle are congruent. But how do we prove that? How do we prove that these two angles are congruent? So what we're going to do is we're actually going to use one of the axioms, one of the 10 axioms. So we know that, let's say this is a angle 1, this is angle 3, and this angle is 2. Okay.
Yep.
Okay. So now one thing we know, angle 1 plus angle 2 is what? Because angle 1 plus angle 2 is on the line here. So therefore, angle 1 plus angle 2
It's 180 degrees.
is 180 degrees, which we call a straight angle. Now, how about angle 3 plus angle 2?
180
angle
degrees.
3, angle 2. So it's also 90 degrees, which means angle 1 plus angle 2 is equal to angle 3 plus angle 2, right?
Yes.
So therefore, we have to see something common here. And if we take out angle 2, then angle 1 has to equal to angle 3, right?
Yeah. Yep.
So that's one of our common motion that, remember, if A is equal to B, then A minus C equal to B minus C, right?
Yep.
So now we know this is actually based on one of the common notions, which is the reason we say common notions because that's applied to all branches of math, not just to geometry. And you'll see that this rule actually is one of the fundamental rules of algebra. Good.
Yeah.
Okay. So knowing we know the triangle congruency, then we be able to do a lot of things from this point on. So one of the things is bisect the angle. And we talked about that a little bit last time, but it's always good to review it and so that you can you understand it perfectly. So let's see how we do that. Okay, I did that. I thought I took this out. Annotate. Okay, I don't want to annotate again. Oh. Okay, so what we're going to do that we can draw an angle. 1, 2, 3. Oh, we actually have no lines here. Line segment. Here to here. Okay, so how do we actually bisect angle? So here you see the 71 degrees within bisect. And remember, when we're doing Euclidean geometry, all we have is a straight edge and compass. So we can only draw straight line and a circle. So the first thing we're going to do, we draw a circle. Okay, let's see here. Now we got 2 points. And then what we're going to do, we use those 2 points to draw another circle. We use this as our radius. And this point, draw another circle. And so we have an intersection point. And all we need to do is to connect this to that. So that way we get a perfect bisect. So so basically, let's see if we're going to so we are saying this angle and that angle are congruent. If this is A, this is a B, and this is C, and this is a D. So we are saying B, A, so B, A, D is congruent to C, A, D. Okay. So now we had to prove that. We had to prove that that's the case. It is bisecting. So what we can see here is that if we connect here to here, and if we connect here to here, now we actually have 2 triangles. One is triangle ABD. Another is a triangle ACD, right?
Yep.
Okay, so one is this one. and one is on going to different color. One is this one. Good.
Yep.
Now you can see that as long as we can prove the two triangles are congruent, then of course the angle has to be congruent. So we can prove that BCD is equal to CAD. Okay, so now what we see here, remember AC is congruent to AB, right?
Yep.
This is congruent because we actually is on the same circle. That's why we draw it. And we also know BD is congruent to AB, right?
Yep.
This and that, because that's on the same, this circle, top circle, same circle. And we also know what CD is congruent to AC, right? Or
Yep.
DC. DC is congruent to AC, right? Because that's the both are the radius on the same circle, right?
Yep.
Good. So therefore, if AB equal to AC, and we know BD is equal to AB, and AB is equal to AC here. So then AC is equal to DC. So therefore we got BD is the same as CD, right?
Yep.
So we have this and that congruent, and this and that congruent. So nothing we know this one is the same line. So of course it's going to be congruent to solve. Good.
Yep.
So now we know all three sides, corresponding sides are congruent. So that's our side angle. So therefore, triangle ABD is congruent to triangle ACB. And because that, then the angle BAD, which is this angle, is going to congruent to CBAD, this angle. Good.
Yep.
So this is the, now we have a new theorem that's called angle bisect theorem. That doesn't matter what angle. Give us any angle, we can bisect it. Good.
Yep.
And that you can see is based on the circle. That's from one of the postulates, and also based on the side triangle congruency. So let's looking at another is this time we're going to bisect a line segment. Pick up something new. Okay, we got a line segment. So how we bisect it? Actually, it turns out actually pretty easy. We draw a circle and then draw another circle. And of course, we're going to have here and here two intersections. Then just connect them. And this line will perfectly bisect the segment that's given to us. So let's take a look. Okay, so we're saying we got line A and B, and we draw the line, say C and D. And we say that C and D perfectly bisect. Let's say this point is our E. We are saying AE is congruent to B. Good.
Yep. Yep.
So basically the CD bisect, which means cut in half, line segment AB. Good.
Yep.
Of course, we have to prove it. So how do we prove that? And same thing, we're going to use the triangle congruency. So first of all, we notice AC is congruent to AB, right?
Yep.
Because that's same circle. And when you have the same circle, then any point on the circle to the center is always the same, which is a radius. Now we can go graph something like that. Good.
Yep.
And so we know BC is congruent to BA, right? Which is same as AB. Good.
Yep.
So now we're going to say, okay, this, therefore this and that are congruent. Good.
Yep.
Okay. Now we can also draw this one here and here. And which means okay, it's I don't think we need that. Okay. Oh, where am I showing here? Okay, see that. So we know this and that are congruent. And now we know this one. This is south, so of course it's congruent. So we got CA is equal to CB, and we know CE is congruent to CE south. Good.
Yep.
And let me see. Okay, I know where I'm missing. Okay, we still need that in order to actually, just based on what we have. Okay, we know this angle, AD is also congruent to BD, right?
Yep.
Basically the same circle. So we know those are congruent. Good.
Yep.
And this one is in the middle. So of course, these two triangles are congruent. Good.
Yep.
So triangle CAD is congruent to triangle CBD. Good so far?
Yep.
Which means then this angle and that angle are congruent. Good.
Yep.
Because two triangles are congruent, one on the left, on the right. So of course, all the corresponding angles are congruent. But now we're going to looking at the little triangles inside. Okay. So let me actually using a different color. So now we're going to focus on this triangle and that triangle. Good.
Yep.
And so based on that, we know we already did CA or AC. CA is equal to CB. Good.
Yep.
Let me clear that a little bit. Okay. Okay. Give me 1 second. My computer is slow today. Okay. All right. Okay. So we know CA is congruent to CB. And we know now we know the angle, angle ACE is congruent to angle BCE. So this angle and that angle are congruent. And we'll now this line is common. We share that, which of course CE will equal to itself. So now we have side, angle, side, which means the little smaller triangle AEC is congruent to triangle BEC. So this triangle, let me use different color, and this triangle are different. That's right, are congruent. Because they are congruent, therefore AE will equal to and BE. That means we actually bisect the line AB. Good?
Yep.
Very good. So this something for you as a homework is to get onto Desmos and to bisect an angle and also bisect a line segment. Good?
Yep.
Yeah. So if you need to watch this again, I'll put this, I'll share a link to Rocksmart, and so you can rewatch this. But if you can do it without rewatching this, that'd be great. So just using on the Desmos, and you can bisect angle or bisect line segment. Now, if you have like a physical straight edge and compass, and it definitely, if you can do that, that's even better. So give you some kind of a feel about on this. Okay.
All righty.
All right. So I will see you next week.
Bye.
Sounds good. Have a good week.
You too. Bye.
Bye.
So loud, yeah, darling. Balloon.